Hello viewers, our next topic is regarding the partial pressure of oxygen and percent saturation of hemoglobin. What do we mean by partial pressure? So first of all we think about the partial pressure. Partial pressure है क्या? What is partial pressure? So partial pressure of oxygen. We just write it in the symbol like PO2. It means partial pressure of oxygen. Partial pressure is nothing, it's just the contribution of pressure of an individual gas in the total atmospheric pressure, if you're talking about the air. I'm just repeating. One individual gas, how much pressure exerting in the summation pressure of a medium is called its partial pressure. I'm giving you an example. What about the pressure of air in the sense of ATM, atmospheric pressure? We say that the atmospheric pressure of air is 1 atm. So atmospheric pressure is always equal to 1 atm, isn't it? 1 atm. And you know that oxygen present in the air is about 20%. 20% oxygen. So how much contribution of oxygen in 1 atm? So if oxygen is 20% in air, oxygen is 20% in air, it means 20 upon 100. So what will be its contribution in 1 atmospheric pressure? That should be equal to 0.2 atm. Means this 0.2 atm is the partial pressure of oxygen in the sense of atm in the air. So 1 atmospheric air consists of 0.2 atmospheric pressure of oxygen, which is the partial pressure of oxygen. In the same way, nitrogen may have a 0.78 atmospheric pressure, atm, and so on. So there are 3 different methods, techniques of calculating partial pressure in the sense of units. If we talk about the kilopascal, kilopascal is also a unit of pressure. So we say that 1 atm of air is always equal to 100 kilopascal. So oxygen, 0.2 oxygen means 20 kilopascal. So 20 kilopascal is the partial pressure of oxygen in kilopascal, and 0.2 is the partial pressure of oxygen in atm. Same, right? We also calculate atmospheric pressure into millimeter. You also know that 1 atm is always equal to 760 millimeter of Hg. We used barometer to calculate the pressure of air. So in this case, if 1 atm is 760, then 0.2, which is the oxygen, should be equal to 154 something millimeter of Hg. So these are the 3 different calculations of partial pressure of oxygen. So the sum, we say like all these calculation means that partial pressure of oxygen, that's PO2, is always equal to 0.2 atm, which is equal to 20 kilopascal, which is equal to 154 mm of Hg. All these are the partial pressures of oxygen. Same. In sense of carbon dioxide, in the air it is only 0.03%. So if you calculate the partial pressure of carbon dioxide, it should be 0.03 kilopascal in the sense of kilopascal, and then you convert it into millimeter as well and ATM as well. So these are the partial pressures. But we are not only concerned to partial pressure. Our topic is partial pressure of oxygen and percent saturation of hemoglobin. So percentage saturation of hemoglobin, HB. Hemoglobin is a transporting molecule. What do you mean by transporting molecule? Any one of the molecule which can, which can bind something with itself and carry it to the respective target area. We say it's like a transporting substance. So hemoglobin in the blood bind oxygen with itself. Oxygen binds with the hemoglobin to form oxyhemoglobin. Now this oxyhemoglobin should be brought about to different respiring tissues in the blood and reach their respective target cells where they should be unloaded to provide oxygen for respiration. So here, the most important point to keep and focus that any transporting molecule, if it is an ideal molecule, it must possess two properties. Number one, to bind, to capture, to load a molecule, and also very easily to unload the molecule as well. If you have a car and you just give lift to someone in your car, and then you are not able to stop your car, and the car is moving, and you are waiting just to finish the fuel, then the car will stop. So that's not a good and ideal transporting substance, because you have picked up someone, but you are not able to drop it. So it's not like the case. You must also have to drop it at the target area where this person is wanted to be dropped. So the same in the hemoglobin. It's not important to pick up oxygen only, but it's also important to drop oxygen in the respiring tissue. Unload. Now there are four features. There are different circumstances where hemoglobin likely to pick up oxygen, and there are certain situations where hemoglobin likely to unload the oxygen. What are these situations? There are four different factors on the basis of which we are going to explain that when hemoglobin will pick up the oxygen and when it will drop it. Four important features. One, before to discuss these four features, I'm just giving you one equation. So we say like hemoglobin, which is Hb plus 4O2. It reacts with 4 molecules of oxygen because each hemoglobin has 4 prostatic groups, as we discussed in chapter 2. It is a reversible reaction, and it will mix as HbO8. Each hemoglobin has the ability to bring 8 oxygen atoms to the respiring tissues. In this case, the forward reaction is called saturation. Yani hemoglobin is going to pick up oxygen. And the backward reaction is called dissociation. Dissociation. So for a transporting molecule, it is very important that it must possess both of these two features. Loading of oxygen and then unloading of oxygen. This reaction initially as a reactant in the lungs to get oxygen, in the pulmonary artery. And this reaction is in the blood, and the blood is now able to transport oxygen to the respiring tissue. Once in the tissue, this situation should be returned back to release the oxygen, and that oxygen now will be available for the respiring tissue. for the respiring tissues. So both the properties, saturation and dissociation, these two properties makes hemoglobin an ideal molecule. Because in normal cases, if one molecule likely to pick up someone, how is it possible that the same molecule will dislikely to pick up? Because if a molecule has both the properties, both likening and also disliking, according to the situation, that is an ideal molecule, and that's the hemoglobin here. So we say, like in this case, saturation. There are 4 features which may affect both saturation and dissociation. What are these 4 features? One by one. Let's talk about, first of all, partial pressure of oxygen. So, the higher the partial pressure of oxygen, the higher will be the saturation. It is saturation of hemoglobin. They are directly related. The higher the partial pressure of oxygen, the more oxygen available in the blood, more likely hemoglobin will pick up the oxygen instead of dissociation. So the forward reaction will be promoted. Saturation will be promoted by high partial pressure of oxygen. In this case, you cannot unload oxygen from hemoglobin because hemoglobin is not ready to leave oxygen if there's a high partial pressure of oxygen. So, high partial pressure of oxygen in the alveolus air, in the lungs, and that's why much more oxygen will be picked up by the blood RBC in the lungs. And then, when you are in the respiring area, in the respiring tissue where respiration takes place, most of the oxygens are going to be used, and instead of oxygen, carbon dioxide is going to be released, because in respiration carbon dioxide gas is released. And this carbon dioxide, partial pressure will be increased in the respiring tissues because of the formation of carbon dioxide, because of oxidation in our cells. So we say partial pressure of carbon dioxide inversely proportional to saturation of hemoglobin, means it is directly proportional to dissociation. So partial pressure of carbon dioxide, if it decreases saturation of hemoglobin, it means it tends to stimulate hemoglobin to unload oxygen. It prepares it for dissociation, not for saturation. So the higher the partial pressure of carbon dioxide, the lesser will be the saturation of hemoglobin. The higher the partial pressure of oxygen, the higher will be the saturation. Both are opposite. The third point is the pH. The higher, the lower the pH, the lower the pH, the more will be the dissociation and the lesser will be the saturation. So once again, saturation is inversely proportional to the pH. Now, think about that. Carbon dioxide is constantly producing in the respiring tissues. And in the respiring tissues, carbon dioxide production makes the pH low. Why? Because you have been told in chemistry that carbon dioxide has acidic properties. So when carbon dioxide dissolves in the plasma, in the tissue fluid, it lowers the pH. This lower pH triggers the hemoglobin to release oxygen. It promotes dissociation and decreases saturation. So lower pH, lower saturation. So it's like that equation, to saturation. Lesser pH, lower saturation. We can't say higher pH because we talk about the normal pH. It is normal pH, more saturation of hemoglobin. But it's low pH, less saturation of hemoglobin. And then temperature. The same relation again. The higher the temperature, the lesser will be the saturation. So in this case, we see that lesser the saturation of HB. So what's the summary? 4 features we have discussed. One by one I'm going to tell you again. Number 1, saturation is the forward reaction. More oxygen will be picked up. Means, if you're talking about the forward reaction, you are saying that hemoglobin is getting picked up oxygen. So if these 4 features, now what are the features which promote saturation? For this forward reaction, I'm just writing here, forward reaction, forward reaction. If you want to make faster the forward reaction, what should you do? There should be high partial pressure of oxygen. Right. Clear? High partial pressure of oxygen. Low partial pressure of carbon dioxide. Normal. I mean neutral pH. And finally, low temperature. These 4 will promote the forward reaction. But if you want to promote the backward, the backward reaction to unload oxygen that is taking place in the tissue fluid. So then it's opposite. For backward reaction, backward means this one. Backward means dissociation of HbO8. So high, instead of high, low partial pressure of oxygen. Instead of low, should be high partial pressure of carbon dioxide. Instead of neutral, low pH means acidic environment. And instead of low temperature, high temperature. Because all these features which you can see here, they takes place where? In the respiring tissue actually. So when you talk about the respiring tissue, in the respiring tissue temperature should be high because kinetic energy, heat energy is going to be produced. pH should be lower because of the production of carbon dioxide, which is acidic in nature. High partial pressure of carbon dioxide because it's continuously producing. Low partial pressure of oxygen because it's constantly consuming. So this enable the backward reaction, unloading of oxygen from the hemoglobin. And of course these are the features which are normally, you can see all these features in the lungs. In the lungs we have high partial pressure of carbon dioxide, low partial pressure of carbon dioxide, neutral pH basically, and usually normal temperature. So these are the features. So see you in the next video.